Hello, good morning. This is Osvaldo Bascour, and I'm going to talk about the digital plan template for operational insights and enterprise strategy. This is a series of video. We started with the basic visualization and analysis, and now we're going to go a little bit deeper into what we call the really the AF setup for the template for the unit. And basically what happened is that in this digital plan transformation, we got a lot of raw data and we need to add the right context. And that context is going to be the different elements that we are going to design with this unit template to catch all these events which are related to the operating conditions of the plant. So when you get data and events, we form information which generates insights. And the third part is going to be related to how, once we get that, we can generate predictive models, soft sensors, and things like that. So this is kind of a step-by-step process. So we start with this very clear business goal, and we are trying to improve a business process. This business process is going to be how far we are from the plan or the scheduled plant that has been set up, and we are going to compare to the reality. So this is maximize yields and reduce operating costs is our business goal. And we are going to show you how this was set up so we can extract and visualize the information for analysis. When we get that extracted, we can also then use the subset for modeling. So this is the business processes that we have, let's say, in a refinery, where you got the management, planning, and the engineering kind of defining proposals and approval in implementing how these different plants are operating. And the scheduling plant is going to set up some of the process targets for every unit in a refinery. And then we are going to capture and transform that into insights, which is going to give us the yields for the different products that we are producing and the cost based upon the energy, water, or any associated consumable. You can add all of them in this template. We just keep them very simple just to demonstrate the capabilities of our PI system infrastructure. So basically what happened is that you get these simulation tools and then everybody does their planning. So those are the targets. The metadata is where we have this object, which is called the unit object, and we are going to run that through this unit template. And that's what I'm going to explain to you in a minute. And then you can see those things as we saw in our previous video. So we acquire the data, we validate the information, and we are going to talk today about the classification for analysis. And this is what we are seeing in PyVision and in all these visualization tools like Power BI, for example. So this is the model of a typical little plan, and you start with this macro thing, and you define the different elements that you're going to use, and you apply it with the unit template. So let's go and take a look at that. So here we are. This is PyAF, and I'm running on a virtual server. And we have these element templates. So this we are connected to the library. This is very important. So the library is going to give us this unit template that you are going to apply to the different templates as you are going to see. So this one just have all the consumables. It has the process feed rate for the unit, for each unit. And that's what you do. Basically, you have a very unique way of terminology that you start using. The water consumption is the water consumption for any unit. And those are going to be related to the attributes that are going to be connected later on the element itself. But this is the unit template. As you can see, a unit template doesn't have any tags or any real data because it's just a template for all the units that we are going to do. The most important part here is that we have these triggers which are defined by your plan and this mode, which is the calculation. And I'm going to show you that because that's one of the most important things in the presentation that is going to show you the, the mode, which is here. So the mode is basically, as you can see here, is basically the different states that are going to be triggering the event framing that we are going to have. So this one is showing us the expressions for the generation of the different states. And when we have that state, we go to the event framing. The event framing tells you what are the different states that you are like a running state. So when it's running, the mode will be running, and we capture that set of time that then we can aggregate the data according to this set of intervals, which are generated automatically as the units are going to go from one side to the other one. Importantly is that these asset triggers are taken from a database where for every unit, in this case, we have defined the desalter, and the other ones that you can see here are organized in a way that will enable us to uh, catch the different sets of data that we need. And in the process area, for the flow rate, we have the desalter, the grid unit, the vacuum tower, the gas processing, the catalytic reformer, and so on and so on. All of these are here available for looking at the data and generating the data, because here we are using some kind of a simulator. Another important thing is that we do have also, as you know, here the design of our most important part, which is the unit event frame. So here we define for any asset that we have that we define as a template in this object, we have the duration, we have the mode, which is captured by the Pi Analytics, the feed rate, which is what we are measuring for every unit, and then we are doing some calculations that you can see here based upon the different methods that we can aggregate this data. As you can see here, this one, we have this very nice environment where we have all our algorithm, and here we are doing the totalizing from a maximum, or you can define all of these other ones if you want to. But in this case, we are going to set up the maximum, the minimum, the total, and you can define a standard deviation. So you can use this as a method to analyze the data as the system is going to identify differences and calculations that you can define your process. So now that we have defined these couple of things, we are going to go into the elements for our environment. And here we are going to go into our elements. As you can see here, we got the refinery, which is set up with the desalter. And as you're going to see, the attributes for this one, again, are basically the template that we just talked about. So it is becoming to be a cookie cutter approach. And now when this one has the data that we are generating automatically and is calculating the mode, in this case, this one, as you can see, is running in trouble. And of course, you can do a lot of ways of defining this. So you can look at the time series of this trouble. And of course, this one is going to give you all the um, um, back and forth troubles that you might want to have. And this is generating the event framing later on, as you are going to see. So this is basically a way to visualize that the simulator is running and the calculations are running okay. We can take another one like the catalytic reformer. As you can see, it's the same structure that we have here. And as you can see, there is no data in this case because the table didn't have that. So I did that on purpose to show you that if you don't have the data, that's okay. You can always enter that data again, and this is going to start working correctly. So we have, this is one of the examples that we have, and the most important thing that we want to go now is I'm going to change to another database just to show you that this technology can be used for all kind of plants. So we're going to go back to this Mineral Pro. So this is going to be very similar to this one. And we are going to go to another environment where we have a different type of plant, where we have a concentrator and we have different areas of the plant that we are going to check for their production schedule in terms of the reality that is going on. Let's look for this flotation just to give you an example. Again, as you can see here, we got the same variables. You can add, subtract. This is the variables that you really want to check. And in this case, we do have the downtime trigger, electricity trigger. And in this case, this unit looks to be in as you can see, in maintenance. Let's look at the primary grinding. The primary grinding now, this one is running okay. But the most important thing here that we are allowing the Pi system to detect all the changes and to aggregate the data so we can see it in Pi Vision. So now we are going to go to the most important part, which is the event framing. As I was saying, here we got all these event frames which has been catched by the system. We got the duration, the start time, the end time, and of course we can have severities. We can add those into the database so we can alert that, and that's going to be visualized in PyVision when you got on this. We got all these units here that are transforming the raw data into the total consumption, the minimum, the maximum, and the different states that we have that. So this is a huge database, which when you start using it and you can see it in your PyVision, it becomes very, very active and you can do many things with this subset of data. Just to refresh that, we can go back into our um, environment and share that. Uh, I have it here in a in an environment. That's the database that we have, and then you can do modeling. You can present that in a very nice way, so you can have every unit and you can go and check the states. And when you have that available, you can go and look at some of the details of that unit and what you can mm, navigate, and most importantly these event frames becomes available. So when you click in one of those, you get to see here the electricity consumption and everything, that if you are making money, not making money, and so on. And then when you finish with that, you can even go further, extract that data and visualize it in what we call a Power BI, which is a Microsoft tool, and you can create that in your desktop, import that through ODBC, and you get to see the performance, and you can do many type of analysis here. When you finish with that one, we are going to go in our next um, lecture on how you have classified the data. Now we can use mass balances, we can do prediction, we can run predictions, things like that, because we are doing this data validation, classification, modeling, and we'll go from there. So to summarize, basically what we have done today is that we are showing you or how you generate a process template which has the basic ingredient for every area of the plant. You put some analysis to characterize the different states according to your business proposition on how they're running good or not good. And then we generate the event frame which aggregates the data for further analysis. So in this 4 step to success, we are going to we have finished here. We have shown you this. Originally, we started with the step 2 because that's the visualization. Now we show you how you prepare the data using this PyF event frame setup. And next time we're going to go and analyze the modeling. And then we're going to look at many findings where customers have been able to generate tremendous amount of value by using these couple of steps to generate their goal, which is to maximize the yields and to reduce the operating cost. Well, thank you very much and looking forward to speak again to you in the next show.